This is an equation of a circle question from the June 2007 AQA Core 1 examination. As you can see, the question is split into three sections. First part asks for the coordinates of C and the radius of the circle, so we're going to attempt that first. Part B is verify that the points of N lies on the circle. We've then got sketch the circle, find an equation of the normal. And then part C, we've been given a coordinate, we've got to find the distance PC, and part 2 we have to then find the length of the tangent drawn from the P to the circle. So here goes, here's the solution. Okay, fairly straightforward the first one. Obviously the centre's at -3,2 from the equation. The radius is the square root of 25, which equals 5. Some candidates get confused here and write 25, so be careful. As we work our way through part B1, we substitute the values into the equation, and you should end up with 9 plus 16 equals 25, and so therefore a correct statement, N lies on the circle, will gain full marks. Part 2 is just a sketch, and that would be sufficient, 4 full marks there. Part 3, if you then do a little sketch, if it helps you, Cn, the gradient will be -4,3, and if we then write it in the form of y equals mx plus c, you know that the intercept on the y-axis is going to be -2, therefore y equals -4 over 3x, take away 2, or equivalent, will gain you full marks. For C1, again, I always find the sketches very helpful, and you'll apply Pythagoras, so the change in the vertical is 4, the change in the horizontal is 5, so therefore PC squared must equal to 5 squared plus 4 squared, and so PC is the square root of 41. Again, that gets you full marks for that part of the question. And for the final part of the question, again, I always find a sketch is helpful, and if you were to draw a little sketch, you'll see that you've got a right angle triangle. You know one of the short distances is 5, the length of the diagonal is square root of 41. If you then substitute that in, I've actually taken T to be the point of contact of the tangent to the circle, so PT squared is equal to PC squared, subtract R squared, and if you put your values in and evaluate, you'll end up with an answer of PT equals 4, and that gains